Okay, welcome to this presentation or short tutorial on loading and querying semi-structured data into the Snowflake data warehouse platform. So we're going to do three activities. Loading some JSON is the semi-structured data into Snowflake. We're going to also load some CSV structured data in. We're going to curate and query that data, that JSON data, using our SQL interface. And finally, we're going to visualize some of that data in Tableau. We're going to join the structured and semi-structured data together and query them. So the scenario, basically the question that we're trying to solve at the end of this tutorial is the question which has come from Baby Boss there. Are there any properties for sale in Islington that are below the median value? We're going to use the data from ONS, publicly available data from the UK government on housing sales throughout the years. We're also going to use some data from Zoopla's API, which is the semi-structured JSON data around property listings for properties currently for sale in the Islington area. And that's going to get loaded into a ZS housing database in Snowflake. So the build itself today, we have an S3 bucket. We have that ONS data from the ONS website sitting in our S3 bucket in Amazon. We also have our Zoopla API JSON data has been pushed into the bucket as well. We're going to load that into our Snowflake platform and set up a few schemas to curate and manage that data. And finally, we're going to visualize that in Tableau. Snowflake partners with a number of BI tools, Tableau, Looker, and MicroStrategy. But in this instance, we're going to be using Tableau. Okay, so the first steps. When wanting to load data into Snowflake, you obviously have to create a database. And then we do two other things, which is we create what we call an external S3 stage. So that allows Snowflake access into that bucket. We also have a file format that we need to create to tell Snowflake, okay, this is the format of the ONS data, and this is the format of the Zoopla data, which is JSON. Just a quick look at the bucket. We have a Snowflake Academy bucket sitting within S3 and folders with the various CSV files and JSON data within it. So we're just going to log in to the Snowflake user interface to perform these activities. Now I've set up dual factor authentication on this account, so I'm just going to get a push to my mobile. Okay, so this is the Snowflake user interface. Very simple, easy to follow, but essentially you can run all SQL through the web-based user interface, so no software to install. We can connect with other SQL clients as well, but you can use the Snowflake user interface to manage and run SQL against the database. I'm just going to switch to the sysadmin role to run these commands, so you can be a member of multiple roles. The first thing we're going to do was create that database, which we'll call ZS Housing. And we're going to create our schema staging, where we're going to push that data. Next step is to create those file formats and those stages that I talked about. So if we go to our database tab, click into our newly created database, no tables or views in there yet. If we go to our stages tab, we can create a reference to our S3 bucket, which is the middle option here. We can connect to Microsoft Blob Storage as well. Now we're going to call that Snowflake Academy. We're going to create it in our staging schema, and the URL is the name of your bucket in Amazon. You can get your secret key information from IAM in AWS. So this is giving Snowflake the security, the credentials to be able to access that S3 bucket. It's managed within my AWS account. You can create all these via SQL commands, but I'm just using the UI for the purpose of this demonstration. So we've created a stage to reference that data in S3. We now need to create a couple of file formats for the files. So we'll create a file format called ONSFF for the CSV data. I believe it's comma separated. I think there's a header within those records, and the fields are enclosed by a double quote. JSON data, similar process. We'll create it in the staging schema, but we're going to choose JSON as the file format. There are some optional variables that we can add there, but that should be fine as is. Okay, Now, to make sure that that's worked and that we've created that successfully, we can use this list command, which is going to go in and ensure that Snowflake does have access to that bucket. So straight away, by running that list command, you can see all the files that exist within my bucket. I've got some XML data in there, some JSON data, and our CSV data. So that's showing that we were successful in creating that, that external stage into our bucket. Next step is to actually load the data in. So we want to load the data. So at the moment, we've just got a reference to our data in S3. We need to load that into Snowflake. And we need to spin up a virtual warehouse or an ETL compute cluster to do that. First off, though, we need to create a table, obviously, to land that data. So our housing sales data from the ONS. Now, to load data into Snowflake, we have what we call a copy into command. So this is copying into the housing sales from that stage and from within the housing folder within that stage using the file format I created earlier. Now, the one thing that I need to do, though, is create that ETL virtual warehouse, or that compute cluster. This will be dedicated just to loading and doing ETL. We'll do a medium. We don't need multi-cluster. That's for high concurrency workloads. We'll have it auto-suspend after 5 minutes, so you're only paying per second while this is running. And we can set it to auto-resume so that as a new load comes in, it automatically spins up. So you only pay for Snowflake when the virtual warehouse is running. So that's started, ready, good to go. So we can start loading using that ETL warehouse. So I just want to change the worksheet to use the newly created virtual warehouse. And we're going to issue a copy into command to load that data into our newly created table. What you can do is also have a look at a query and what Snowflake's doing behind the scenes. And this is a live representation of all the going-ons in Snowflake and the number of rows being processed by Snowflake as it loads data in. So we can see 21 million rows, it's still running. That's on a very small warehouse. The larger your compute cluster, the quicker that will be. But this is a really good representation of how what Snowflake's doing behind the scenes, how many bytes of data are being scanned. We also get a fully a set of completion stats as to how many rows were loaded, and we set our error limit to 1, but there were no errors in this case. Just to confirm that was loaded, let's just do a quick select star from that table. So we can see now we've got some of the sale prices, the postcodes, and the date of the sale within there. One of the things I will quickly touch on as well is another cool feature in Snowflake, which is our undrop feature. So as DBAs can do, myself included, we can accidentally drop a table from time to time. So let's drop that newly created table. And then we'll try and select from it. Housing sales does not exist. Whoops, that was an accident. There is a feature in Snowflake. You can turn it off and turn it on, but it's turned on in this case. And that time travel feature effectively allows you to query a table at a point in time. And we can use that to actually undrop a table using this undrop command. So if I run an undrop command and then run my select star, the table is brought back to life. You can do that at a full database level. So the worst case, if someone dropped an entire production database, you can actually undrop the entire database. That would have saved me many of hours of problems having done that in my past life. So the ONS CSV data is loaded. Now we're going to go move on to the JSON Zoopla data. Okay. We're going to use the database set as housing, use the same schema. Now to load JSON data into Snowflake, we've created a particular type of column, which is called a variant. So it's a very simple table to create. So we've got our Zoopla JSON data, and we just create one column, which has got a column name called listing as that variant data type to support JSON. But we also support XML, Parquet, Avro as well. Now let's just, so what we're going to do is we're going to use the UI to actually load this data. So we could load from the bucket again, but I just want to show you that you can load data through the UI as well. So if we go back to our schema browser, we can see we've got our 21 million rows in housing sales. If I click on the Zoopla table and click load data, which of those compute clusters or virtual warehouse. I want to use that ETL when I create it. The source files I can load from a bucket. I might actually load them from my computer, so you can load data from your computer as well. So if we move into the Snowflake Academy folder here, go into the Zoopla data, I'm going to select all these property listings from my computer. Click Next. Now I want to use that Zoopla file format that I showed that I used before. We can set what happens if it encounters errors. We're just going to load with the default. So behind the scenes, that's issuing that copy into command as the same as before, but this is just using the UI to do it in a different way. So we're not transforming this JSON, it's being loaded in its raw format, so in its raw JSON format, and we'll query that after it's loaded. So what the UI is doing here, because I've loaded via the UI, is it's encrypting the data before it moves it from my computer into Snowflake. So all data in Snowflake is encrypted at rest. So 100% of data, you don't turn it on or turn it off. We encrypt all data before we load it into Snowflake. So that gives you that extra confidence that your data's secured behind the scenes, as well as all the additional features on top, which is user privileges. We have roles, so certain people can access certain tables and certain schemas. Just wait for that to finish. So the encrypting is probably actually going to take longer than the load itself. Okay, so there are multiple listings within these, but it's only passing one row because it's loading one JSON file for each of those. So they were loaded successfully, which was great. Now what we can do is have a look at that JSON data that we just loaded. So it's in its raw format. So this is what the Zoopla API sends us back. So there's no need to transform it before it goes into Snowflake. We see some JSON data. What's the area these properties exist in? That's the N1 postcode within England, London. The agent we can see there, and some description about the agent. But then you also have an array here of listings. So we're seeing multiple properties in here. So a whole bunch of properties with number of bedrooms and some other information about price changes, number of bathrooms, number of floors, things like that. So not much use in its raw form like that. It's very hard to get any real meaning out of it, although you can have a quick browse. Using Snowflake's JSON SQL notation here, path notation, we can start to get some data out of that JSON and start to query it with regular SQL. So we can see area name there is a tag within that JSON. So if we query the listing field, remember I called the variant type listing, and then we're going to start to probe into that by pulling out the area name and casting as a string. And it's as simple as that. It's pulled out N1. So all the properties that I loaded today were from the N1 postcode. The next feature that I'll show you though is even more powerful. You've got the ability to do a lateral flatten. So I showed you that there was an array within there, an array of listings within this single JSON. So there's 10 properties in each of these files, but we've only got one record at the moment. What you can do is do a lateral flatten on the listing column and within the listing array. So you have the column and then the array within that column that we want to flatten out. Now, as we flatten that out, it's going to create multiple records for each of those listings. And then within the listing, there were a few fields in there: street name, the displayable address, the number of bathrooms, the number of bedrooms. Again, we're just getting the value, the tag name, and then the casting it as a type. So straight away we start to get what looks a bit more like a structured set of data. We haven't altered the raw data in its raw format, so we can load the data in without quite knowing how we're going to use it, and then the analyst can start to dive in and start querying that and start to get some real value from it. So we can see here the address, the street name, and the price of the property for sale on Zoopla. Now what we can do on top of that is the more advanced users might be querying the JSON data, but we want to visualize this in our BI tool. That was our end goal there. So what we're going to do is we're going to start to curate that and create some views on top of it. So we'll create a curation schema. And we're going to create a view called Zoopla listing, which is doing a few more things than the previous one, but very much the same. We're just trimming some of those values, so all the SQL that you're used to using. So we're going to do some trims. We're converting these to upper cases and doing the regular casting. But we're going to create a view on top of that. Okay, so I've just got the wrong schema. So my browser's set to the default schema as curation, so I'll just change that. I want to create that in my new schema, which is my curation schema, just to separate staging from curation. Let's try that again. Let's just put the schema name in there. Okay, that's created that successfully. And the structured data, so we're going to combine the structured data with the semi-structured data. So again, we're going to create that in the curation schema from that staging housing sale, and this is the structured data. And I'm just doing some simple SQL aggregations here to get the median price out of that ONS data. Okay, so we've created a view on our structured and our semi-structured data. Now what I can do is actually join the Zoopla listing JSON data with the CSV structured data. I'm going to join on street name and area name on the street White Lion Street, just to give you a bit of a demo as to what you can do on top of that. Now, I'm just going to have to put my schema names in there. So effectively what I've done there is I've combined structured and semi-structured. So the price of this property for sale is $519,000. The median sale within White Lion Street is $500,000. So already you can start to see the power of what we're doing there by combining JSON with structured data. Now the final step was to actually visualize that JSON data in Tableau. So what we're going to do is we're going to create a warehouse separate just for Tableau to use. The benefit of that is that Tableau is never going to compete with the loads. So even if we were continually loading data using our ETL compute cluster, Tableau is unaffected by anything ETL is doing. It's still accessing the same data, but it's got its own compute reserved just for Tableau. Okay, so BI started, ready to run. ETL is suspended now because it's not, we're not loading any data, so we're not paying for that one, but we will be paying for the BI instance while it's running. So let's connect to Snowflake. We just need to put our Snowflake account credentials in. Okay, Snowflake has a native connector into us, so we can choose which virtual warehouse compute cluster we're using, which was the BI one we created. And we're going to select the database ZS housing. That's where we loaded that data in. We're going to use the curation schema because that's where those views were that I set up. We're going to drag in housing sales street. I'm going to drag in our JSON Zoopla listing data. Now the joins made a join on area name because that happened to be the same column name in each of those, which was N1. What we also want to join on is street name, which didn't do the automatic join. And we'll make it an inner join so that we only get records where there is a join. We can do a quick update now. Tableau is firing this query against Snowflake, and you can see straight away that we've got a bit of that data similar to the SQL that I ran before. Now if we go to our worksheet and start dragging some of this information in, we can drag in our listing ID, we can drag in the price, and we can drag in the median sale as well. Now straight away, actually I might also, straight away we can see there that there's a couple of outliers, probably because of commercial selling in that street of 60 million there as the median sale. So what I'm going to also do is put a filter on. I'm just going to say if it's above $1 million, it's probably not residential, so let's filter those out. Okay. So straight away, I think I've answered Baby Boss's question, because we're looking at the median sale on a street, and this is the sale of the property 44275570 in Islington. So we can see they're selling for $1 million, but the median sale on that street's only 400,000. So if we browse along, we kind of want one where the blue indicator is larger than the median. Sorry, the orange indicator is smaller than the median. So the median sale is 288, the price of that. Now, one of the other cool things we can do is actually drag in a URL into here as well. So that's also part of the semi-structured data within Zoopla. Now, if we go to our actions sheet within Tableau and add an action, we're going to do a go to URL. So for sheet 1, we'll call this a Zoopla link. We're going to say URL and listing ID. Click OK, and click OK again. Now, if we want to see a particular property, we can click on this Zoopla link. Straight away, we can see a link to Zoopla. Now, that property mustn't be for sale anymore. Let's try another one. Let's try this property here. Right, that's expired as well. So we can see that that was a parking garage for sale in Railway Street. So next step maybe would be to exclude properties of parking garage type. Then if we jump onto Dove Road, this is selling for $375. Median sales a bit above that at $424. Okay, we've got a 2-bedroom flat in Dove Road, but that's already under offer. So that's just an added benefit of Tableau about grabbing the URL from Snowflake in JSON in its raw format and going to Chrome and the website. So that's it for our presentation on querying semi-structured data and structured data in Snowflake. If you want to trial this yourself, please do get in touch. Thank you.